All right, guys. So we're going to finish up the note sheet from Tuesday, finishing up this addition subtraction. Now, before we get started with the notes today, are there any questions over the previous assignments? So we haven't had an assignment over 7.41 yet. We are going to finish up the note sheet here. 8x. So for this here, we want to factor the denominators first so we can figure out what the least common multiple or least common denominator is going to be, or really get it so the denominators are the same. Now 12x squared is as simplified as it gets. We can't factor that at all. Now on the other side, x squared plus x, we can factor out and x from both terms. If we factor an x out of x squared, we're left with x. And x from x is 1, so we get x times x plus 1. Now we do need to get the two denominators to be the same so that we can actually add them together. Now we can start off with the one on the left, so 12x squared. We need to see what does the right side have, our x times x plus 1. What does this have that this one doesn't? So the right side does have 1x, but the left side has 2 of them, so it's fine there. The right side has x plus 1, the left side does not, yes? So we need to multiply it by x plus 1 on top and bottom. Because the right side does have 12, but since the left side doesn't have any number besides 1 out in front, we don't have to do anything with it. Now if we look on the right side, it is missing the 12, so we multiply 12 over 12. The right side only has 1x, the left side has 2 of them, x squared, so we also need to multiply it by x. Now we can multiply the denominators first just to make sure we do have them the same. So on the right side we do have 12x squared times x plus 1. Because if we have monomials, single terms outside the parentheses, we will multiply those together and then the parentheses with the rest. All right, guys, so we'll keep going here. So we're multiplying those together. Now we can do the one on the right as well. Now since the x is out front, we can multiply it with the 12x. And 12x times x will be 12x squared. Thank you. Then we have the x plus 1 also. So the two denominators are the exact same. Now we can go on and multiply the numerators. So 8 times x is going to be 8x. 8 times 1 is going to be plus 8. And on the other side, we have 12x times x, which gives us 12x squared. Now we can add the numerators together, which will give us 12x squared plus 8x plus 8. Since it's only one term in the second and we're adding, we don't have any kind of sign issues to deal with, so we can just add these together. Any questions on this so far? Is there a greatest common factor between our three terms in the numerator? 4. So we'll need to factor it out. So if we factor 4 out of 12x squared, we're left with 3x squared. 4 factored out of 8x is going to be 2x, and 4 factored out of 8 is 2. And the reason we do this is because of this 4 over 12 here. Because that will reduce, that will simplify. And 4 over 12 reduces to over 3. So we have 3x squared times x plus 1 in the denominator. The numerator is going to be 3x squared plus 2x plus 2. And that is as simplified as it gets. 3x squared plus 2x plus 2 will not factor, bless you, or simplify any further than that there. The 3x squared and 3x squared, it's very tempting to want to simplify that down or cancel those out. But the 3x squared plus 2x plus 2 is one whole term. We can't just break those two apart. Questions on this here? All right, let's look at another one. This time we're finding the difference, so we're subtracting. So this time we're subtracting. Now we need to be careful, especially with the numerator of the second one when we do subtract, because the signs are going to change based off of that subtraction. Now before we start subtracting, we're going to need to get the denominators to be the same. The numerators x plus 2 is just still going to be negative 2x minus 1. Bless you. Now when we look at the first denominator, 2x minus 2, we can't factor using parentheses, but there is a greatest common factor between 2x and negative 2, and that is 2. So if we factor that out, we're left with 2 times x minus 1. If we look at the denominator of the second rational expression, x squared minus 4x plus 3, there is no greatest common factor. Kind of a giveaway is that x squared is by itself, and 3 doesn't have an x, so there's no greatest common factor. But since the 3 is positive, our signs are the same and they match the sign of the middle term, so negative and negative. X squared's factors are x and x, and the factors of 3 are 1 and 3. Okay. So we have all the denominators factored, yes? So now we need to make the denominators be the same so that we can subtract. So which one do we want to start with first, the one on the right or the one on the left? Left. So we have 2 times x minus 1. What does the one on the right have that the one on the left does not? X minus 3. So we're going to multiply top and bottom by x minus 3. So, yeah, so the one on the right, so they both already have 1x minus 1, yes? So they're good there. The one on the right doesn't have any number being multiplied in front, so we don't have to mess with that. So the x minus 3 is all it's missing. Now let's go the other way. What does the one on the right have that the one on the left does not? So 2 over 2, yes? They still both have that x minus 1. They now both have the x minus 3. So that's it. Now we can multiply these together. So the one on the right, we have 2 times x minus 1 times x minus 3. And the one on the right, 2 times x minus 1 times x minus 3. So we've multiplied those together. Now, we're going to need to multiply the numerators. So for the one on the left, we can go on and distribute this out. So we can do x times x is x squared. X times 2 is going to be plus 2x. X times negative 3 is negative 3x. And negative 3 times 2 is negative 6. Now we do need to multiply the numerators out because we're going to have to add or subtract. Here we're going to subtract the like terms in both, so we'll need them multiplied out. We don't do it in the denominator because once we simplify the numerator, we're just going to simplify down. Luckily, the other side is just multiplying by 2. Negative 2x times 2 is negative 4x. Negative 1 times 2 is negative 2. Any questions up to this point so far? Now we can combine like terms. So here we'd have x squared minus x minus 6 over our 2 times x minus 1 times x minus 3 minus negative 4x minus 2 over 2 times x minus 1 times x minus 3. Now we can put them all on the same fraction. Now this time we put the parentheses up because when we subtract something, we're changing the sign. Because when we say we're minusing negative 4x, well, a negative and negative make a plus. Minus negative 2, the negative and negative make a plus. Even if one of those had been plus 2, the negative and positive would make a negative. We're changing the signs because we're subtracting. When we're using addition, it didn't make a big difference. Because if we add a negative 2, it's still just negative 2. It's not changing signs. So, at this point here, we can say x squared minus x minus 6. Distribute this negative, which will give us plus 4x plus 2 over 2 times x minus 1 times x minus 3. Now we can combine like terms. Well, x squared is by itself. Negative x plus 4x is going to be plus 3x. Negative 6 plus 2 is negative 4 over 2 times x minus 1 times x minus 3. Questions on this here so far? Hold on a second. Now the question is, will x squared plus 3x minus 4 factor? Yes. What do we think one of the factors will be? So since the 4 is negative, our signs are opposite. Factors of x squared are x and x, yes? Now the factors of 4 are 1 and 4 or 2 and 2. Which one do we think is positive? Because what do we have on top and bottom now? It's the same on top and bottom, yes? So that's kind of how we wanted it to factor, because if something's going to reduce, we need something in common on top and bottom. We kind of knew it's probably not going to be x minus 3, because 3 is not a factor of 4. So most likely we would need an x minus 1, which will cancel, leaving us with x plus 4 over 2 times x minus 3. Questions on this here? There's a lot to it, but on a whole, the difficulty of what we're doing isn't really high. It's not a really difficult problem. It's just a lot of little steps, yes? It's a lot of little easy steps that we can do one at a time. And again, I need to keep saying this more, but a lot of times with Algebra 2, the problems in them of themselves as a whole are not difficult. There are lots of little easy steps. But if you try to tackle everything all at once, it does become harder. Questions on these here? Do we feel pretty comfortable with these? Because let's look at, wow, we're looking at the right one, yeah. Yeah, okay. Do we want to see another example of one of these here? Do we need to see? Let's look at 14. I want to look at this one here. Yeah, so I typed this one up in the in the computer. It's handwritten out there. I want us to do one of these here. So we have 3 that we're adding and subtracting. We're adding 2 together and subtracting 1 from it. So we're going to rewrite it out, leave a little bit of space in the middle, because again, we need the denominators to be the same. So we're going to end up multiplying all 3 of these by something. Now, first step is getting the denominators factored, then we need to get them to be the same. So if we look at the first one, x minus 4, there is no greatest common factor. There is no greatest common factor between x and 4. There's no way we can factor it. It is as simplified as it gets. So we have 2x. So x is as simplified as it gets. It's one term, no greatest common factor, nothing we can do to it. Last one, 4x. X squared minus 16. It can factor. And it's a special one. It is our difference of perfect squares. X plus 4 and x minus 4. Because x squared is x and x, 16 is 4 and 4. So we get this here. Now we just need to pick which one of these 3 we want to start with. So 2 over x.
Can we cancel out the x to negative 4? Not now, we can't do that?
Because x minus 2 and x minus 4 are different. Now, so 2 over x, so it has an x. So what does it have? What does x minus 4 have that x doesn't? Well, x minus 4 is one whole term. So it's missing n, x minus 4. And then the other one, yes, we will also need n, x plus 4. Now in all 3 of these, x minus 4 in each one only appears once. It appears once in the first, it doesn't appear any in the second, and it only appears once in the third. So in all 3 denominators, we only need x minus 4 once. X plus 4 shows up in the last one, yes? How many times? So in each of these denominators, we only need it 1 time. So that means in the first one, we do need n plus 4. So that takes care of those. We have x minus 4 and x plus 4 now across all 3, yes? Yes, we need an x in the first. And we need it in the last. Now we have all 3 denominators the same. Because it's going to be x times x minus 4 times x plus 4. Now, x times x minus 4 times x plus 4 plus x times x minus 4 times x plus 4 minus because I'm just making sure. Yep. This is supposed to be that. Because it's plus and then minus for this last one. Now, the first one, so we have x times x plus 4 times x minus 2. We're going to do these part by part. We're not going to try to multiply x plus 4, x minus 2 all at once because that's a lot to try to do together. So we'll do the x plus 4 times x minus 2 first. So x times x is x squared minus 2x. 4 times x would be plus 4x. And 4 times negative 2 is negative 8. So x squared minus 2x plus 4x minus 8. Now the next one, we have x minus 4 times x plus 4, yes? So this one here, we can think of it as quote-unquote cheating, but it's not really. Where did we get x plus 4 and x minus 4 from? That's the factors of what? X squared minus 16, yes? So we're multiplying x plus 4 and x minus 4. Well, where do we get it from? This here? So it should multiply back together to be x squared minus 16. So on a lot of these problems, if you see, hey, these are the two factors that I got from a quadratic or a polynomial above, we're going to replace them back to that. And it's nice because, well, like here, I'm going to have to simplify the middle term out. Well, if we already know how this middle term is going to simplify, might as well simplify it back. Our last one, 4x times x, is so the middle one, we can do it first because the middle one's going to be a little bit easier because we're just multiplying it by 2. 2 times x squared is 2x squared and minus 32. The last one's still 4x squared. Now the first one, do we want to combine the two middle terms first or multiply through by x? It really doesn't matter at this point because we only have a single term out front. If we had another set of parentheses, so another x minus 2 or x plus 4, I would combine the middle terms first and then multiply. But since it's just a single term, we're just multiplying all these by x, which would make it x cubed minus 2x squared plus 4x squared minus 8x. Questions on how we got to this part here? All right. We're going to put these all under 1, over 1 fraction, and merge them into 1 fraction. Now we're going to do kind of 2 steps here all at once. One of them is kind of putting them together, and 2 is combining like terms. Because this first one here, we have x cubed. Negative 2x squared plus 4x squared is plus 2x squared minus 8x plus 2x squared minus 32 minus 4x squared. Because I did those 2 steps in one because I believe that there is something that y'all can do. We move it down, make them all 1, and just combine those 2 terms together. So we have x cubed plus 2x squared minus 8x plus 2x squared minus 32 minus 4x squared. So really we dropped the parentheses and adjusted the signs if needed. The only one that was going to have a sign change is the last one that we're subtracting, but it really just made it minus 4x squared. Combine like terms, well, x cubed is the biggest one, and it's really by itself. There's no other terms like terms with it. X squared. So we have 2x squared plus 2x squared is minus 4x squared. 0. So all the x squareds are gone. Then we have minus 8x, because that's the only term with x minus 32 over x times x minus 4 times x plus 4. Not too often, because again, I think this might be something I pulled from a college algebra kind of note sheet. But again, I will say this, most of college algebra is taking essentially what we do here, and it's just a little bit that they add to it. It's not a whole lot different. But again, guys, we are now offering it here. So, all right, guys, that is it for this here. So the homework is on page 392, 4 through 6, 8, 12 through 14, 20 through 23, and 26. So 12 problems.